Hello and welcome to another tutorial. We're looking at operators in Java, and we said that operators require precedence so that when the Java compiler tokenizes each line of your source code that includes or involves operators, then it knows how to order the operators, how to execute them when it writes the actual executable bytecode instructions for the JVM, right? So we said that so this table provides us a very nice visual way of understanding the precedence of operators. The postfix, plus plus, and minus minus, these have the highest precedence. The unary operators, after that, they have the highest precedence. So first postfix and then unary. Unary operators, this is the prefix plus plus or minus minus. And remember that these plus plus and minus minus only operate on integer types like byte, short, int, long, okay? And then plus and minus expression, these are basically, plus is it's not useful, we typically don't use this operator. Minus expression is for negation, so you can negate an expression if it evaluates to a numerical value, you can negate it. And then tilde for bitwise negation, so you flip the bits of a number, and then exclamation mark, which is for not and operates on boolean. So tilde operates both on I believe integers, non-integers, I believe any type integer or float, we can test that. So let's start with the postfix, or before that let's go through all of this. After that, multiplication, times, division, and also modulus. So previously we said that if we have an expression like this, multiplication and division happens first, but modulus operator, which is for finding the remainder of an integer division, it also has the same precedence as multiplication and division. And whenever you have operators with the same precedence, we said that the rule of thumb is that they get evaluated from left and right, just because we're typing English, right? So let me just move these, let's basically create a new class operator precedence, and let's have a main method. Let's have a method test1 and public static void test1 here. And we want to test operators with the same precedence, operators with the same precedence. And what we do, let's say that we know that multiplication, division, and modulus has the same precedence. So int a1 or a equals 10 or 51, and then b equals 10, right? And then let's say we want to say var a or x1 is a divided by b modulus 5. So we know that let's say 57, for example. So 57 and then modulus 2. The question is, what's the order of execution? What's the order of execution? So let me zoom in on this. So a divided by b modulus 2, and the way this works is that division and modulus, they have the same precedence. So what the compiler is going to do is it's going to start writing the bytecode in a way that this expression gets executed from left to right, right? So execution from left to right, from left to right. Let's add the semicolon here. And in order to see that, first of all, let's look at the result. All right, so I'm gonna put this expression also as a string, and let's see what happens. Let's run this, and as you can see, we get 1. 1 means 57 divided by 10, which is basically 7. Because remember, this is an integer division, so 57 divided by 10, it just gives us 5, right? Because we lose the remainder, because the compiler assumes that you're doing the integer division, so whatever remainder it is, you just get rid of it. So you get 5 modulus 2 is 1. We wanted to also test if we can use modulus with negative numbers, And we can also apparently use negative numbers, 0, right? And then let's say -3, 2. So 5 modulus -3 is basically 2. 5 modulus 3 plus 3 is 2 also. And then what we can do is, first of all, we can check the bytecode. So operator precedence, let's look at, open with this is the source. Let's go to Java file, operator precedence. Let's open this with a class file viewer. Let's put these side by side and let's go and zoom in. All right, so what do we have? We have test1. We push 57 to the stack and then store it in location 0 of the stack. Remember, this is a static method, so index 0 doesn't point to this pointer, right? Non-static methods, the first address or the first position on the stack holds the this pointer. But here we don't have it, so the zeros on this, the zeros element on the stack is already a, the variable, right? We don't have this because it's a static method. And then we push 10 to the stack, store it in the location 1, and then we're loading zeros, index of the stack, which is a, right? And then we're loading b, which is the index 1, the second index, and then we do an integer division, I division, which means now in the bytecode the integer division is getting executed first. And then we load the 3 in the stack, right? We load the 3, and then IREM, integer remainder. So modulus translates into the integer remainder bytecode operation. So we do the division first using the IDiv, and then the result is goes into the modulus operator with the 3, and then we store it in the third index or index 2 of the stack, which is x1, and then we get the static method print static field, print a stream, and then we create a string builder. So basically, if you're not familiar with string concatenation, I believe from Java 9, 10, at some point they decided to make sure that you always do a string builder. Now obviously for this case, creating a new string builder might not be the most efficient way, because if you recall, a string builder constructor, the one that doesn't take any parameters, I think by default it allocates 16 characters, right? However, I guess in this case we have less than 16, right? 1, 2, 4, 5, 6, 7, and then for example 8 if we concatenate these. So in the bytecode we create a string builder, and then we load this string constant, LDC load constant, and invoke a special. It just means we are invoking the basically the constructor of the string builder to create it. We load index 2 of the stack, which is holding the value of x1, right? And then invoke virtual, we invoke append to a string, and then so this really seems to be inefficient for this string concatenation. We will look at this kind of things that happen in the bytecode in much more depth in the future lectures, but here it would have been much more efficient if we had just concatenate this, basically convert this to a string and then concatenate these two strings together. But here it's creating a string builder, calling the append on it, and then call the to a string on the string builder, and then call the print line method of this print stream, the out, right? So if I go to a string builder class, so let me put this back here. Let's go out of the full screen, and if we look at the constructor that doesn't take any parameter, you see by default it allocates 16 characters, right? And then we saw that in the bytecode it's actually calling the constructor that takes a string, which makes sense, right? So it's calling the constructor that already takes a string, and what's it's taking, it's actually calling this a string literal a divided by b modulus 2 colon space. So this string literal is automatically passed to the string builder, and we only call the append to add the x1 value to it, right? So append integer, it automatically uses the toString method, right? So we use this constructor that takes a string, and a string builder is a final class. You cannot override it, and then it comes from as abstract string builder. So it just has a byte buffer, and know that it doesn't have a char buffer. It uses a byte buffer because it's more efficient, right? And then obviously we also have a encoding scheme, what encoding to use. Remember, char in Java has at least 2 bytes. That's why we're using byte. And the problem, or something that you might not be used to, is that in C or C++, typically for characters, we try to use unsigned char, right? Unsigned bytes, but Java doesn't support unsigned integer, right? So we use byte, but it is still assigned. So you see the empty buffer is byte 0 with 0 elements in the buffer, and there's a lot of stuff in this abstract string builder. And then a string builder has a method append, lots of append, and it also has lots of insert and also replace, right? So a string builder just provides append, insert, and replace. So again, it's very good for you to look at the bytecode every once in a while to see how it works, right? Right now we see that it creates a string builder. It might not be the most efficient way, but obviously if the concatenation is you're concatenating like 4 or 5 things together, because I can say x1 plus something here, and then plus x1 again, or a. Now this starts to become more efficient if you just go with a string builder route, right? But for concatenating a raw string literal with some number, it's more efficient to just go with the string.concat. So in this case, for us, a string.concat is so basically, if we could just basically, let me just show you. A string has a concat method. It creates a new object. So dot concat, right? Is not for argument int, so we have to convert this to a string. So maybe append it with a empty string. So concat only accepts a string. Note that x1 is not a string. So we're doing a conversion here with the empty string, and then we use the concat. These are all the same, but the compiler is doing the string builder route, right? Now let's try to see what happens if we have x2. We know that these operators have the same precedence, so eventually the division goes first from left to right, and then we do a modulus for x3. What if we were to do the modulus first? Now obviously we expect a different result, but let's do this. So sysout all right, so sysout x2 plus x2, and then sysout x3 plus x3. So the results are different, right? So b modulus 3, 10 modulus 3 is 1, and then 57 divided by 1 is 57, and here we're getting 2 because 57 divided by 10, it's an integer division, so you get 5 modulus 3 is 2. The remainder of dividing 5 by 3 is 2, right? So this is about operator precedence. You have to be very careful. Postfix has the highest precedence, and then unary operators, multiplication, and modulus. Remember, modulus is not multiplicative, but it's ranked as the same as multiplication and division. Additive, plus, minus, these have less precedence than multiplication. Shift, left shift, right shift, and unsigned right shift. Remember that Java doesn't support unsigned left shift because it can result to flip the sign of numbers, so the behavior becomes indeterministic. but unsigned, so right shift is okay, because if you shift the bits to right, the sign is still preserved, right? So there is no undefined behavior or unexpected behavior. Relational, less than, greater than, less than, equal, greater than, equal, and instance of. Instance of for checking if a object is of an actual instance of another class, which means you're checking the class hierarchy, right? Type hierarchy. Equality, equal, equal, not equal. Bitwise and, bitwise exclusive or, bitwise inclusive or. So exclusive or means only one of them has to be true. Inclusive or means at least one of them has to be true, so you get a true result. Logical and, double ampersand, logical or, double pipe. Ternary, we already looked at the ternary, and we said that it's exactly equal to if else statement, and it has very, very low precedence. Assignment and compound assignment, plus equal, equal, plus equal, minus equal, multiply equal, divide equal, modulus equal, bitwise and, exclusive or. Shift left equal, shift right equal, and unsigned shift right equal. In general purpose programming, certain operators tend to appear more frequently than others. Obviously, the math operators always appear a lot. If you're doing Java, C++, usually plus and minus operators also appear a lot. For example, the assignment operator is far more common than the unsigned right shift. So the unsigned right shift operator is, you rarely use it. With that in mind, the following discussion focuses first on the operators that you're most likely to use on a regular basis, and ends focusing on those that are less common. Each discussion is accompanied by sample code that you can compile and run. Studying its output will help reinforce what you've just learned. So the simple assignment operator. Assignment is for assigning values to primitive types and reference types. So for reference types, we typically use the new operator on the right hand side, and it returns a reference to the object that was created, and we assign it to a reference variable. We know that in C++, any operator, or almost all operators, not all of them, almost all of them, can be overloaded. Java doesn't support any concept of operator overloading. So for a defined user type class, you cannot overload the behavior of the operators. And typically none of the operators are supported for a class type that you define, the user defines, because they thought it might make things complicated. Now obviously other programming languages like C++ or Python that allow object-oriented programming, they also allow operator overloading, which in some cases it makes much sense, especially you're doing math stuff. If you have an object that represents a matrix or a vector, it makes more sense, a vector of numbers, for example, right, or a matrix of numbers. It makes sense to be able to overload the mathematical operations so that it becomes much more natural when you write the source code, right, when you type your source code and try to add two vectors together. But Java doesn't allow you to do that, so you have to explicitly type the method that you want to call to do the addition. Now there are ways in Java to allow that, and that burden basically relies on your IDE. If you have an IDE like Eclipse that allows a plugin that can do this, because even though Java doesn't allow you to do directly overload the operators, at the end of the day what happens in the concept of operator overloading is that you have a class like vector, right? So let me type it here. So you have a class here like a vector that has numbers, right? It's just an array of numbers, and you want to add another vector to it. So let's say v1 add v2. So this is and this returns a new vector, right? Returns a new vector, and this is pretty much an allowed code, right? So you can say var v3 is this one, right? So this is allowed code in Java right now. However, you cannot say var v3 equals v1 plus v2. This is not allowed code in Java because you get an undefined operator for type vector, for example. But then you can tell your IDE, if your IDE allows a plugin to enable this kind of behavior, to tell the IDE, not Java. You tell the IDE that whenever you see this plus sign between the two vector types, replace it with this bytecode, a bytecode that corresponds to calling this method, right? This is the entire meaning of operator overloading. Operator overloading, or the meaning of operator overloading. I have multiple tutorials on operator overloading. So if you're not familiar with how to do it in Eclipse IDE, for example, for Java or for other programming language like C++ or Python, definitely check out my tutorials on operator overloading. For example, in C++, when you write this plus in this, so let me just also type it in C++, whenever you write v1 plus v2 at the compile time, right? This is a operator overloading is only a compiler type concept, compile time concept, right? At the compile time, of course, Python supports that, but Python does it at runtime, and it doesn't make that much difference. At the compile time, when the compiler sees this expression in C++, it knows the type of v1 and v2, right? That's the whole meaning of statically typed languages. And then when it sees the plus, it looks for a method that has some sort of signature like operator plus. In C++, you type the name operator and then the symbol of the operator, and that, for example, takes the vector v and returns another vector, right, by value or reference. You're returning a new value, so basically you have to return by value, for example. So this is something like that. Or you can, because this is a binary operator, sometimes you can also define this as a global function in C++. As I mentioned before, in C++ we have the concept of global scope, which means a scope that doesn't belong to any class. But in Java we don't have any global scope, right? So in Java everything has to be contained in the scope of a class between these curly brackets. But in C++, so instead of overloading the operators as a member function of a class, we can also overload the operators as a global. So let me just write this down for completeness. So you can add it as a method or member function. So you just tell it for a method or member function. And what this happens is that obviously we know that whenever a method is part of a class, this pointer is going to be passed, right? Implicitly, we have access to the current object, and then when we invoke this has to basically return this plus v, right? Something like that. But we can also have in the global function, so we can overload the operator plus for a specific user type class in C++ using a global function in the global scope. And if it's a binary operator, which means it takes the two operands, you give it the first operand or the left hand side and then the right operand, and then obviously this returns v1 plus v2. So C++ obviously is much more friendly to operator overloading. It inherently supports that. Java doesn't support it, but again, I've already added a plugin to my Eclipse IDE, for example, that supports that. So if you look at the plugins, or I can just search for operator overloading, Java operator overloading for Eclipse. And what this does is that now if I have a class, for example, let's say class vector, right, and then double x and y, and then public vector double x double y, and then this dot x is x, this dot y is y. And we want to have a toString method, so let's just overload the toString method. Source generate toString x and y. Let's go with this. So this puts it in a nice vector way, right? And then I want to create a vector here. Vector v1 is new vector 1.1 2.2, right? And sysout v1. So this is a code that is allowed, right? And then we're going to create a new vector v2 minus 1.1 minus 2.2, and we can do a sysout on these two as well, right? And if I say vector v3 equals v1 plus v2, this is not supported. Obviously I can go ahead and then say public vector add and then vector v, or other. Usually the convention is to write the name other, for example, here. Here I'm just using v, and return new vector this plus v dot x. Remember that these, even if these are private fields, which the most likely are in the scope of this class, we still, whenever we pass a variable v of type vector, we still have access to them because we are physically in the scope of the class, plus right. And now automatically this plus works because Eclipse realizes that this type v1, which is a vector type, has a method add, and that operator overloading plugin in Eclipse that I have installed, it just tells the Eclipse that, hey, when you compile, remember Eclipse has its own Java compiler and you can patch it, right? And this plugin just gives more information or adds more capability to Eclipse's its own Java compiler. And if I look at the bytecode, obviously you can, this just translates simply to v1.add v2. So it's just a syntactic sugar. That's all I want you to understand about operator overloading. It's just a syntactic sugar for more easily writing the source code, right? We can say v1 add v2. That's what the Java designers want us to always do. But obviously if I want to add another one, then this chaining of the method calls becomes a little bit tedious, whereas v1 plus v2 plus v3 comes much more naturally. So let's test that the addition works fine, and as you can see I get 0 0 because 1.1 plus minus 1.1 is 0, 2.2 plus minus 2.2 is also 0. So I hope you have some good understanding of operator overloading and operators in general. We will continue to look at this the rest of this script about operators in the future lectures. Please stay tuned, and I'll see you in the next one.